Hi guys, in this video I'll be discussing quadratic functions with you and making sure you're comfortable with the types of questions you'll be asked to work throughout the homework assignment. So whenever we look at a quadratic function, the first thing I want to talk about is the two different types of forms that you'll see. So the first form is standard form, where this is helpful for us because we've already been used to stretching and shrinking and shifting functions. So this one is in that form where we can see there's a vertical stretch of a factor of a times a function shifted h units to the left, and in fact it's the x squared function shifted h units to the left, and then up k units. So this a times x minus h quantity squared plus k, that's called our standard form. That standard form is helpful because it automatically easily tells us where the vertex is. We can say, well, it's just the graph of y equals x squared that's shifted h units to the right and up k units. So we know that the vertex, the center of the parabola, is going to be at the ordered pair hk. Now, whenever we're looking at just the general form of a quadratic, it's not as useful as the standard form. I can't just instantly quickly look at that and tell you where the vertex is, but we can still find the vertex, and we'll talk about that later on. One thing that it is nice with this, though, is it's very easy to see what the y-intercept is. Remember, the y-intercept always occurs when x is 0, but if x is 0 in this case, you're just going to be left with c. So that's why I say you can easily find the y-intercept by plugging in a 0, and you'll always get whatever the constant is in your formula, ax squared plus bx plus c. Now, both of these forms, whether it's the standard form or whether it's the general form, that a is the exact same term. And remember, what I'm wanting you to remember about that a, anytime a is positive, that just means your parabola is going to open up. Anytime a is negative, your parabola is going to open down. So that term of a is the same in each of our formulas. And then I can also say about that vertex, I could split the parabola exactly in half. If I set a vertical line and call it the axis of symmetry, that vertical line is always going to be x equals h. Whether the parabola is moving up or whether the parabola is moving down, x equals h is the equation of the vertical line that's going to split that parabola perfectly in half, and you could fold the parabola over that axis of symmetry. Now, let's see this in action and actually work out a few problems. So the first one here that I want to look at with you gives us one where it's already in standard form, and remember, I said that's the more helpful form, especially if you're trying to see what the graph looks like. So if I give you the example 2 times x minus 1 squared minus 8, then what we're supposed to do as part of this problem is first of all realize it does have a vertex that's been shifted 1 unit to the right and down 8 units. And I know it's pointing upwards because a is positive. So just real quickly, I could say that's a rough graph of this parabola right here. I know that it looks like that. But let's do a more precise graph. So yes, we do know that's the vertex, and we do know it's moving upwards. From that, I can also answer the domain and range. Domain of any parabola and domain of any polynomial function is always going to be negative to positive infinity. It moves forever left, forever right. The range is always restricted here. We're always going to have a highest or lowest y value. In this one, before I even do the official graph over here, we can see that that vertex at 1, negative 8, it's going to be the low point on our graph. So my y values would start at negative 8 and include negative 8, and then they go all the way up to infinity. So notice that's why I put for my range, y is equal to bracket negative 8 comma infinity parenthesis. Now, the other things that I want us to be familiar with through here are the x-intercepts. And I can say, well, the x-intercepts are always just where it crosses the x-axis, and that's always when the y value is 0. So notice what I've done here. I've taken my equation that I had up here above, y is equal to f of x, which is 2 times x minus 1 squared minus 8. I set that function equal to 0. Okay, so in order to set that equal to 0, I need to solve for x now to find those x values that satisfy this equation. I moved 8 to the right-hand side, Then after that, I divided both sides by 2. And once I was at this point, I just used the principles of square roots and said, well, if x minus 1 squared is equal to 4, then x minus 1 is equal to the positive and negative square root of 4, which I know is positive or negative 2 on that right-hand side. In this step, I also moved over the 1, so I can say, well, x is equal to 1 plus or minus 2. Now, don't leave your answer like that. We know if it's 1 plus 2, then x is 3, and then if it's 1 minus 2, the answer is negative 1. So I take these two x values and I put them up here into my x-intercepts. I'm going to say, so one x-intercept is at the ordered pair 3, 0. Remember, anytime it's an x-intercept, you take the x value and the y value is guaranteed to be 0. The other x-intercept at negative 1, 0. Now the y-intercept here, all you have to do for the y-intercept, again, remember, is just plug in an x value of 0. So notice all I've done is I've looked at my equation up here, 2 times x minus 1 quantity squared minus 8, and I've plugged a 0 in for x. So that became 2 times 0 minus 1 quantity squared minus 8. And then I can say, okay, I know that 0 minus 1, that's just a negative 1. But negative 1 squared is going to be positive 1. So that's 2 times positive 1 is 2. And then I'm getting 2 minus 8, negative 6. I know my y-intercept is at negative 6. And of course that occurs when x is 0. So I get the ordered pair 0, negative 6. I take the x-intercepts and the y-intercept that I've just done, plot them along with the vertex. And then I also just said, because of symmetry, if that y-intercept occurs when I move 1 unit to the left from the vertex and I had to move 2 up, then I know if I move 1 unit to the right of the vertex, in other words to x equals 2, I would move 2 up. So I went ahead and just plotted the ordered pair 2, negative 6 as well, just to help me graph it in. Plotted my two x-intercepts, connected the dots, drew my graph in there. Pretty nice problem. Now, what if we have a negative parabola? Something like this one to look at. So here, I'm asking you to look at negative 1/2 times the group x plus 3 quantity squared plus 8. So I can say, well, in order to do that, I'm going to go ahead and say, I know that this is a parabola that's being shifted 3 units to the left and then up 8 units. That's how I got this drawing up here. I knew that the vertex was going to be at the ordered pair negative 3, 8, and I do know it's moving downward since it is a negative parabolic function. Now, I go ahead and plug in the vertex. We know the domain is always just going to be negative infinity to infinity. It moves forever to the left and forever to the right. The range here, you take your possible y values and you say, well, this time the vertex is going to be a maximum. So you'd say the y values start at negative infinity. They go up to a positive 8 and include a positive 8. So we have to say y equals parentheses negative infinity to 8 bracket. We get our x-intercepts by setting the equation equal to 0. So you'll notice that's what I did down here. Set the equation equal to 0, solve for x. I had to move the 8 over, became negative 8. Then I had to divide by negative 1/2 on each side. Now be careful with that. If you're dividing by negative 1/2, that's the same thing as multiplying by negative 2. So I said negative 8 times negative 2 is a positive 16 there. And then I solve for x by taking the square root of both sides. The square root of 16 is going to be 4. I'll have positive or negative 4. So then x is going to equal negative 3 plus or minus 4. If I do negative 3 minus 4, I get x equals negative 7. Negative 3 plus 4, I get x equals 1. So I have my two x-intercepts, the first one at negative 7, 0, the second one at 1, 0. My y-intercept I found over here by yet again just looking at your function, plugging a 0 wherever there was an x in it. So instead of negative 1/2 times x plus 3 squared, it became negative 1/2 times 0 plus 3 quantity squared plus 8. Now I said, well, I know 3 squared is 9. Negative 1 over 2 times 9, that's going to be negative 9 over 2. I went ahead and got a common denominator. 8 is the same thing as 16 over 2. So when I add these together, I'll get my 7 over 2 for my y-intercept value. So the coordinate of the y-intercept is 0, 7 over 2. I was thinking in my head, well, 7 over 2 is the same thing as 3.5. That helps me plot it out up here. The y-intercept's at 3.5. Now, once I also plot that vertex in, I know if I move 3 units to the right, the y value is at 3.5. So I also know if I move 3 units to the left at x equals -6, the y value better also be at 3.5. So that's where I got that point from. It just helps me shape my graph. And then my x-intercepts at -7 and at +1, I go ahead and draw in my graph. Pretty nice problem. Now, how about one in which we don't have it in standard form? We have it in the general form. So something like this problem here, the second form we can expect to see the general form where it's an ax squared plus bx plus c. So the easiest way to do this, and you'll notice it's capitalized here, very, very, very important calculation. The way that you need to get the vertex anytime it's in this form is that the x value of the vertex is always going to equal -b over 2a. And notice b is just the coefficient of the x to the first, and a is the coefficient of the x to the second term. So whenever you're looking at this problem, you can say, well, all right, that's going to help me figure out what the x value of the vertex is. And then once you find out that x value of the vertex, you just plug it in for x, and then the y value is going to be the y value of the vertex. So you'll plug that in for x inside the equation and solve for y to get the y value of the vertex. Let's show you an example of that. So I have the general form -3x squared plus 24x minus 42. So when I'm asked to find the vertex, I come down here and say, well, the x value of the vertex is -b over 2a. In this case, that's -24 over 2 times -3. I went ahead and simplified 2 times -3 is -6. -24 divided by -6 is a +4. So I know the x value of the vertex is 4. Now to get that y value of the vertex that I have written up there, I have to go back down and say, well, the y value of the vertex is when you evaluate your function at the x value of the vertex that we just found. So I have to find f of 4. I go in here and say -3 times 4 squared plus 24 times 4 minus 42. That's what I've done right here. I went ahead and showed the work for that. 4 squared is 16. -3 times 16 is -48. 24 times 4 is 96. Then I have minus 42. -48 minus 42 would be -90 plus 96. Gives you the 6 for the y value of the vertex. So I know that my vertex is at the ordered pair 4, 6. Now before I worry about part C, now I've already drawn it over here, but I'll reference it later. Before I worry about that, you really need to find the x and y-intercepts first. So let me talk about how I did that down here. Please remember, your x-intercepts, you always just set your function equal to 0. So I took the function that, and I forgot to talk about this, when I asked you to rewrite in the standard form. So we had the original problem in the general form. If I ask for standard form, once you get the vertex, you already know what the standard form is, because we already knew a in this problem was a -3. So the standard form is always a times the group x minus h quantity squared plus k, where hk is your vertex. So I knew that hk in this problem was 4 and 6. So this exact same problem in standard form is going to be -3 times the group x minus 4 squared plus 6, because this parabola is being shifted 4 units to the right. That's why you see the -4 in there, and then up 6 units. And it's being stretched by a factor of -3, which means it's moving downward and stretched by a factor of 3. Now, I set that equation equal to 0, and that makes it pretty easy to solve for. I move the 6 over, it becomes -6. Then I divide by -3 on both sides, and I get a 2 on the right-hand side. I take the square root of both sides. X minus 4 is going to be the positive or negative square root of 2. and that's like 1.414, but I did say exact solutions up here, so let me keep that exact. When I move the 4 over, my two x-intercepts would be at 4 plus or minus the root of 2. So the smaller one is going to have the x component of 4 minus the root of 2 and a y value of 0. The larger x-intercept is going to be 4 plus the root of 2, and again have a y-intercept, or sorry, I have a y value of 0. The y-intercept, super easy in this problem. We always just remember it's when x is 0. Well, if x is 0 in this problem, the y value is just the constant, the negative 42, which is what I plugged in here. Now, what I've done to graph this one out, especially since I knew that that y-intercept of negative 42, my grid only went 8 positive y values and 8 negative y values, same thing on the x-axis. So I didn't have to worry about the x values. I didn't need to scale them. My x values don't get very large in what I need to graph. But in order to include that y value in there, what I've done is I've changed the y increments to multiples of 6. So this would be 6, 12, 18, 24, 30, 36, 42, and 48. Now the reason that that helped is because I already see that my vertex has a y value of 6, which means, oh, all I have to do is go up 1 unit. So I plotted that vertex at 4, 6. Notice I did not scale my x-axis, so I actually have to go over 4 units and then only up 1 to represent a y value of 6. Now, my x-intercepts were at 4 minus the root of 2 and 4 plus the root of 2. I had to kind of think of that in my head and say, well, 4 minus the root of 2, that's approximately 2.6. It's like 2.586. And then 4 plus the root of 2, that's approximately 5.414. So I went to about 5.5 and about 2.5 there. You can't be too precise with that. So I just approximately put in where those would be. Those are labeled exactly though, the 4 minus the root of 2 and the 4 plus the root of 2. Now I went down and I did my y-intercept. In order to account for a y value of negative 42, remember I had to go in increments of 6. This would be negative 6, negative 12, negative 18, negative 24, negative 30, negative 36, negative 42. I can put my y-intercept at 0, negative 42. Now I know if I go over 4 units to the left, my y value is negative 42. So if I move 4 units to the right, my y value would also be 42. So that's where I got the ordered pair 8, negative 42. Doesn't have to be a part of your graph. I just find it helpful to have another point to determine the symmetry and get the shape right. So after that, you graph in your function. The next page, what if we have numbers that don't fit so nicely, have decimals and stuff like that? So whenever we're dealing with the quadratic functions, the absolute maximum and minimum values are always going to occur at the vertex, which we already knew that. But now if I give you an expression in terms of variables with decimal coefficients, just means you're probably going to have to use your calculator. No big deal there. So if I have one like negative 0.32x squared plus 122.6x minus 13.6, and I'm asking you to determine its absolute maximum or minimum. Now instantly we already know it has an absolute maximum. It's not going to have a minimum because this is a negative parabola. It's going to be pointing downward and it's going to have a top point. So you'll see I found the location of the maximum. The way I found that was I went in and I said negative b over 2a. In this problem I can see that the b term is 122.6. Well, the formula negative b, so I'll go ahead and create a fraction on my calculator by hitting alpha y equals fraction. My numerator, negative 122.6. My denominator, 2 times negative 0.32. And, not 5 times, 2 times. Need to hit enter in the right number. Now, I'll get my answer. So you see the 191.5625. Now I need to type that number into my equation there. Now the way that you can do this, you can do it just like I have written here, which is perfectly fine. Or the way I would even prefer you to do this is to just take that answer you just got and store it in for x. Now my calculator is going to think x is 191.5625. So now I can just type in the equation 0.32 x to the second, and then I'll have plus 122.6 x minus 13.6. And you'll see, whoa, let's see what I did wrong here, guys. So I have 0.32 x squared, yes. Oh, it's a negative. My calculator covered up the negative side there. So let me fix that. I'll go second enter, go back to the first term. Yeah, I just did that intentionally so you could see me insert in a negative. All I did is I hit second delete to insert in a negative, and now everything's going to be gorgeous. I'll have the negative 0.32 x squared plus 122.6 x minus 13.6. Boom. You get your 11,729.18125. Now, for my next problem here, I was asking you, it says if a quarterback, that was a typo, not snaps to the receiver, passes to the receiver, this function is going to represent the height of the football given any distance downfield in the number of yards in terms of x. So it says models the pass where x, what we're inputting into the equation, represents the number of horizontal yards from the quarterback the ball has traveled, and y is going to represent the height of the football in feet. So I know that the peak position of that, and notice again it's a negative parabola, which makes sense. It's going to be shaping, it's going to be pointing downward, and you're going to have a maximum point here. So we're trying to find out when is the peak height of the football. Well, the x is going to tell me when the peak height of the football occurs. In other words, how many yards downfield will the ball hit its peak. So all I did there was, once again, I said the x value of the vertex is going to be at negative b over 2a. So I can say, well, negative b over 2a in this problem, negative b, that's going to be your negative 2.1. And then I'm dividing that by 2 times 0.04. Let me do a fraction instead. I think that's a cleaner way to do these problems. So I'll say negative 2.1 divided by my denominator of 2 times negative 0.04. Close it like that. And you can see you've got your 26.25 just like I did. And now, in order to get the y value of the vertex, I've shown it out by hand how you would work it. You would just plug the 26.25 into the equation. On the calculator, it's even easier. You just say, I need to store that value in for x. And then once you do that, type your equation in. In this case, the equation was negative 0.04 x to the second plus 2.1 x plus 6.1. I get that in, and I can say absolutely, that worked out pretty nicely there. And I can say now whenever we're looking at this throughout the problem, I know that the x location of the vertex is going to be at 26.25 and the y is at 33.6625. Now, with that in mind, I come back down. This is just asking what is the maximum height the ball reaches. Well, that's always the y value. It's going to reach 33.6625 feet high. When does that occur? How far downfield does this occur? It occurs when you're 26.25 feet. And again, that's understood to be from the quarterback. So that's, sorry, that's not in feet. That's bad. The x values in this problem were measured in yards. So please keep that in mind. I need to change that to be correct. So the x component in this problem was measured in yards. So I need to be correct in my notation. Again, maybe I just did that to keep you more alert about mistakes like that. Not really. This last one. If the receiver misses the pass, how far downfield does the ball land? Well, that's just when you set your function equal to 0. The easiest way to set this function equal to 0 is to use the quadratic formula. I'm not a huge fan of the quadratic formula, as you probably know, but it does work pretty efficiently for this problem. I take this equation and I can say, okay, I know this is ax squared plus bx plus c. The quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now it's just a matter of plugging the numbers into that equation and then solving it out on our calculator. So I've done that down here. Now I need to show on the calculator how that will work. So I'll say, well, again, it's a fraction. I'll go ahead and put my fraction in. And then I'll say it's negative 2.1. I can't do the plus and minus, so I'll go ahead and do the plus first. The square root of 2.1 squared, 2.1 squared. And then minus 4 times a times c. So I'll have minus 4, and instead of parentheses, I just usually use the times sign. So times negative 0.04 times c, 6.1. So I get that in there, and then divided by 2 times negative 0.04. This should be absolutely fine. But now, you see I got the first answer I had down here, and I slashed through that answer. The reason I slashed through that answer is because it's trying to ask you how many yards down the field is this ball going to reach, or how far down the field is the ball going to go before it reaches the ground. Well, it doesn't make sense to have a negative value down here. So since it says downfield, it's assuming it's a positive pass. You're not going to pass it behind the quarterback unless the quarterback gets sacked or something. So I'll say that's not a reasonable answer, not part of the domain of this problem. My other one here, I should be able to go in and say, well, I can get that answer by saying it's the exact same problem, except I need to go in here where there's a plus sign and change that to a minus. So the negative 2.1 minus that square root gives me the 55.25969, which I would just go ahead and round to 55.26. But again, that is an x value in the problem, and x values in this problem are not measured in feet, they're measured in yards. So let me correct that right there. So it's 55.26 yards down the field when it hits the ground. The last problem in this section that I want to talk about with you is when we're looking at the area of fencing. And again, this is just me trying to do another quadratic application problem with you. So we're trying to find what the maximum area would be if we're fencing in this region and we only have 1,200 feet of fencing. Now, the side of this blocked in region that's adjacent to the river, we don't have to fence in that. The river is a natural barrier. But then all of the other regions I do need. And then notice it says that you're going to make 3 equal spaces by having 2 dividing walls. And whatever the length of those dividing walls are, you need those to be the exterior walls as well. And then we need another wall that's going to be parallel to whatever the length of the river is here. So I can go in and say, well, I know that area of any rectangle, this would be a rectangular region overall, is just length times width. So I'll call the area of this rectangle in this case the length, which is x, times the width, y. I know it would be x times y. Okay, but I know y, it says we need to get this in terms of x, so I need y to be a function of x. So I need to get y in terms of x. That's what I did over here. Because we knew that the perimeter of this fenced-in region had to be 1,200 feet, so I knew that I would have to add all the lengths of these x to the length of the y to get the 1,200 feet, which told me that y has to be 1,200 minus the 4x there. So then I take that expression, that's the expression that y is going to be equal to in this problem, and plug it back in into the place of y, and since y is f of x, then I can say the area as a function of x. Please don't think of that. Some students mistakenly think, well, why is he saying a times x? I'm not. This is function notation. Area with respect to x is equal to the length x times the width 1200 minus 4x. At that step, I went ahead and distributed the x through, and I put it in descending order to get a negative 4x squared plus 1200x. Then I came down here and said, well, the x value of the vertex is going to be negative b over 2a. So that's negative 1200 divided by 2 times negative 4. And you see that's negative 1200 over negative 8. That simplified to give me a 150. Then I took that 150 and I plugged it back into my function up here. I said negative 4 times 150 squared plus 1200 times 150. That's what this is right here. And I got an answer of 90,000 for that. So I know that the vertex, it's just the x value of the vertex, y value of the vertex. The vertex is at 150 and 90,000. Now, remember, the y value of the vertex always gives you the maximum in a problem like this. We knew this was a negative parabola, so its vertex is going to maximize the function. This function has a maximum enclosed area of 90,000 square feet. Now, the x value just tells me where that occurs. Well, that this is 90,000 square feet when this dimension is 150 feet. So notice, when it asks what should the dimensions of the rectangle be to get the most area, well, we already know x is 150. Now the other dimension has to be 1200 minus 4x, so that's what I said right here. The length would be 1200 minus 4x, so that's 1200 minus 4 times 150, it's 1200 minus 600, 600 feet. And then as a way to double check yourself, I said note down there on the end, you could easily say 150 times 600, this better be 90,000, or else these are not the dimensions that yield 90,000 square feet. But they are. So you can say that is conclusive evidence that we are correct in that problem. That problem's a nice one. So make sure you understood what I did in that one, and there should be some similar quadratic applications in your homework assignment too, I believe. Okay, that'll be it for the section 3.1.